Hey guys, in this video I want to show you how to make a fluid explosion effect using custom forces in Houdini, so let's dive in. So if you want, you can get access to this final project file, including all previous tutorials and all future tutorials with a link in the descriptions. So I've created a new blank scene, and the first step is to add a new geometry node. So you can dive inside, and now we can set a very basic fluid simulations. So as a base geometry, I will use a spheres, but you can use any geometry. So here for the spheres, I will change the primitive type from polygon mesh to polygon. And here I will increase the frequency to 10. And I will keep the radius at 0.5, which is the radius by default. So now I can convert that to flip source with a flip dop source node. So for now I will keep everything by default, but later we can change some settings and link some settings based on our dop simulations. So now let's add a null to specify this is the output for the source. So we can rename it out source. So now let's add a dop net to set the fluid simulations. And here for the dop net, you can rename it flip sim. So now you can dive inside and we can set a very basic fluid simulation. So let's put the animation at the frame number 1. So first let's add a flip solver. You can plug that to the output. Let's add a flip object. You can plug that to the first input of the flip solver. And let's add a volume source. And you can plug that to the last input of the flip solver. So now we can link some parameter from the dop to the SOP. So you can copy the particle separations, right click, copy parameter. And now you can go back to the SOP by clicking on the Geo1. You can go to the flip source, and here you can paste the value on the voxel size. So right click, paste relative reference, and you can multiply that by 2. This is a grid scale value, and we can keep it by default at 2. So now we can paste the value here on the particle separations. So paste relative reference. And you can keep everything else by default, as we will emit the flip only at the frame 1. So now you can go back to the flip setup. And here we can remove the default cube that we have with the flip object. So we can remove that under the SOP pass.
Most Houdini tutorials show you tricks. Very few teach you how to build real, production-ready setups from scratch. Artilabs is a premium Houdini training platform for artists who want production-level results, used in motion design, simulations, and high-end product visuals. You get 45+ hours of advanced content, including 2 complete courses where you build high-end animations from start to finish, exactly like in real client work. Every lesson includes full Houdini project files, so you're never guessing. You follow the exact workflow step by step. The library keeps growing every month. And right now, annual access is discounted with an extra 20% off for a limited time. Click the link below. Start building Houdini work that actually attracts professional clients.
So now let's import our source on the dop. So to do that, you can select the volume source node. Here on the SOP pass, you can import the out source. So you can select the null here under Geo1. You can select the out source node. Click on accept, and here under initialize, you can initialize the source flip. So now you can see that we have the spheres under the dops. And now you can go to the flip object to guide, and you can go to particles, and you can change the visualization from sprite to particles. So now you can go to the flip solver, and here under the substep, you can increase the substep number. For the minimum, you can set it at 6, and for the maximum, you can put the value at 8. So now you can go to particle motions. You can add an ID and add an age particles. And now you can go to the receding tab, and you can disable the receding particles. So now you can go to volume motions, and you can change the velocity type to swirly. And here for the box size, you can put the value at something like 10, 10, and 10. And you can disable the box size from the viewport. So to do that, you can disable the little checkbox here. And you can go to the viscosity attribute, and you can enable the viscosity. And now you can go to the surface tension, and you can enable this parameter. So here for the surface tension, I will put the value at 35, but of course it's up to you. You can play with different value to get a different result. I will add a bit of blur to the surface tension. So here I will put the value to something like 0.05. So now we can set a value for the viscosity. If you want to control the viscosity by an attribute, you can go back to the viscosity tab, and here you can enable the option to control the viscosity by attribute. But in my case, I will set a fixed value for the viscosity, so I will keep this one disabled. So now I can go back to the flip object, and under the physical tab, I can set my viscosity value. So in my case, I will put the value at 100. So that's pretty much it for the flip simulation setup. It's very, very basic simulations. So now we can decrease the particle separation just a bit. So we can put the value at 0.05. And now we can set a pop wrangle to create the custom forces for the simulations. And you can plug that to the second input of the flip solver, which is particle velocity. And here we can create some noise to animate the fluid simulations. So first, let's create a vector at the origin of the scenes. So to do that, you can create a new vector variables and you can rename it center. And here you can put everything at 0 to get a vector variable at the center of the scenes. So you can open the curly bracket and put 0 on X, 0 on Y, and 0 on Z axis. So next we can compute a relative positions. So let's create a new vector variables. And we can name this one something like rels. And we can subtract the point position from the center. So let's type at P minus center. So now let's create a little channel for the fall off. So we can create a float and you can rename it something like radius. And here we can create a channel to control that on the UI, and you can just type CHF to create a new channel, and you can call it something like fall off radius. So now let's compute a radial fall off. So first let's start by getting a normalized distance between the radius and the rel variables. So here you can type length, and here we can get the length of the rel vectors divided by our radius. So now we can clamp that between 0 and 1. So you can use the clamp functions. And here we can clamp from 0 to 1. And now you can smooth this result. So let's create a new float and you can call it something like W. So here you can use the smooth functions. And we can smooth from 0, 1. And then you can add 1 minus this global value. And don't forget to close it at the end. So now we can create the different parameter for the noise. So let's start to create a float amp. And here we can create a new channel float to create that with the UI. So here we can name it amp. So now let's create a parameter for the frequency. So let's create float frec is equal to new channel float. And here we can type. So now let's create a new one for the speeds. You can create a new channel float and you can rename it speed. And now we can create the noise. So let's create a new vector and you can call it noise. And this one is equal to curl noise. And here we can use our rel multiply by our frequency plus at time variables, and you can multiply that by our speed, and you can multiply everything by our amp. So now let's define our velocity attribute. So you can type v at v plus equal, and here you can use our noise vector variables, multiply by our fall off, which is here. So in my case, I've called it W. So you can multiply the noise with the W. So now let's add a pop attract. And here for the pop attract, you can set a goals, but in my case, I will keep everything at the center of the scenes. And for the force, you can try different settings if you want, but in my case, I've put the value at 7.5. So now let's add a pop drag. And you can keep the air resistance to 1, but if you want, you can increase or decrease this value. So now let's create the different channel for the noise. So you can go back to the pop wrangles and you can create the different channel by clicking on this icon. And here for the fall off radius, in my case, I will put the value at 0.5. For the amplitude, I will put the value at 2, and for the frequency, the value at 3, and for the speed, the value at 0.5. Of course, you can play with these settings if you want. So here, don't forget to enable the fluid only at the frame 1. So here we can go back to the volume source, and you can type $FF == 1. In that case, we can emit the fluid only at the first frame. So now we can check the result of the simulations. So now we have this result. Of course, you can play with different settings with the noise, the pop attract, and also with the viscosity and surface tension value. But in my case, I will keep it as it is. So now I can decrease the particle separation to have a bit more resolution on the flip sim. So I can select my flip object, and here I will decrease the particle separation to 0.005. So now I can go back to the sub by clicking on Geo1, and I can import my flip simulation back on the sub. So here let's use the DOP import fields. And here I can drag and drop my DOP net on the first field, and for the DOP node, I can select my flip object. So here under my flip sim, I have my flip object, and I can click on accept for the DOP node. And here for the preset, I can choose flip fluid. In that case, I have the flip simulations, and you can see I have around 4 million points in my case. So it depends on your computer, but you can increase the particle separation if you want. So now let's add a fluid compress node. And here we can go back to the DOP net. You can select the particle separations, right click, copy parameter. You can go back to the fluid compress and you can paste it here on the particle separations. So paste relative reference. And now you can disable cull band width. And now let's add a file cache node. And you can rename it something like flip sim. So now you can change the file path to explicit, and you can put that under the cache folder and under the $OS folder. And you can make that in cache for around 150 frames. So you can delete that and put the value to 144. So now you can click on save to disk. So this is the result of my fluid simulation. So now we need to unpack the points. So let's add the unpack points node. And in my case, I have this result. So now let's convert those points to a mesh. So to do that, we will use a VDB. So let's use the VDB from particles. So here for this one, you can put the minimum radius in voxels to 0.1 and you can put the voxel size to 0.05. So now let's add a VDB reshape node. And here for the VDB reshape, you can keep that to delete and put the value at 2. So now let's add the first VDB smooth SDF and you can keep that to min value. So you can copy and paste it and change the operation to Gaussians for the second one. And now let's add a VDB reshape SDF. And this time we can change the type to arrowed and you can put the value at 1. So now let's convert that back to polygon with the convert VDB node. And here you can convert from volume to polygon. So now let's add some normals on this flip sim. So you can add a normal node and you can put that to points. So now let's add a smooth node and you can smooth the position. So you can keep the strength at 10. And now let's smooth the normals. So you can put the attribute name here at n with uppercase. In that case, you can smooth the normals and you can put the strength to 50. So now let's add a null to specify this is the output for the fluid sim. So you can rename it out fluid. And now you can use these nulls for the final rendering with Redshift or even with Karma XPU in Solaris. So that's it for today, guys. I hope you enjoyed this tutorial. I'll see you in the next one. Bye-bye. That's it for today, guys. Thanks for watching and don't forget to subscribe to our channel and check artivoxer.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.